Okay, let's start. So first, thank you for having me here. I wish I was able to travel to Tokyo, but I'm still happy that the conference was able to happen, even online. So today I'm going to talk about how to do functional GraphQL in Scala with a library that I created a year ago called Caliban. Okay, so first, let me introduce myself. My name is Pierre. You might have seen me on GitHub under the Ghost Dog PR username. I'm a French engineer who moved to live in Korea, so I'm on the same time zone as Japan. That is pretty convenient. I work for an online game company called Dev Sisters, and I've been contributing to various open source projects, in particular Zio and several libraries in the Zio ecosystem. And in September of last year, I created Caliban. So first, let me introduce what is GraphQL, because if you don't know what it is, it might be hard to follow. So GraphQL is a query language for creating APIs, basically. It's a little, if you want to compare it with something, you can compare it to REST. So it's another way to expose APIs for clients to consume your data. So what is special about GraphQL is that the server exposes a typed schema. So everything that the API exposes is predefined in what we call a GraphQL schema. And then the client can request and only what they want. So instead of like REST calling several endpoints and getting whatever the server defined as a result, with GraphQL, you can say, I want only this and this and that. And you can also request multiple things at the same time. While with REST, you would call multiple endpoints separately. With GraphQL, with one call, you can receive multiple things that are different. So just like REST, you can use any programming language. This is just, GraphQL is just the format of exchange of data, but it's not linked to any particular programming language. And another thing that is pretty nice about GraphQL is that because the schema is known in advance, the tools are pretty good. You can auto-generate documentation very easily. And there are some tools like Altair and Insomnia, and I think even Postman supports GraphQL now, that show you everything that's available on the server and make it very easy to create queries. I have a small example so you can have an idea of how it looks like. So this is a schema defined in the GraphQL schema language. So what does this mean? This means that we have a query type. So we expose some queries. We have two different queries that we can call. One is called user. It takes an ID parameter and it returns a user. And the second one is called users. It doesn't take any parameter and it returns a list of user. And below you can see the definition of a user. So a user has an ID, a name, and an age. The brackets around user in the query users means that it's a list, and the exclamation mark means that it's non-optional. So for example, the age doesn't have the exclamation mark, so the age is optional. It might be null, but the name and the ID are not optional, so they will never be null. So that is how you define a schema on the server side. And then on the client side, if you want to query that schema, the query looks like this. So here we can see that we called the user query. We pass the argument ID. Here the value is XXX. And we request the name and the age. So you can see in the previous slide, you see that user also has an ID, but because we didn't request it, it will not be returned. The server will only return name and age. Just the same way, here in this example, we called user, but we could call in the same query, we could also call users if you want to get a list and a single user at the same time. Or you could request 3 individual users in the same query. No need to do separate queries. Okay, so this is basically how GraphQL looks like. Now let's talk about it, how to use GraphQL in Scala. So basically in Scala, you have 2 choices. There is a library called Sangria, which was created quite a long time ago at the early stages of GraphQL. It is a pretty good library with a lot of features. So if you're interested, I recommend you give it a look. But today I'm going to focus on the second one, which is called Caliban, and is the one that I created. One big difference with Sangria is that Caliban can be used for the server, like Sangria, but also for the client. And it supports Scala.js, so you can even do GraphQL queries in the browser using Scala.js and Caliban. So first, why did I decide to create a library when there was already one existing? The main reason, the first reason was that I had an existing REST API that was pretty big, and I wanted to turn it into GraphQL. But I realized that I had to write a lot of boilerplate in order to expose this big REST API with 100 endpoints into GraphQL using Sangria. But this is not a problem with just Sangria. It's something general with most of the GraphQL libraries in any language. That is that you have to write a lot of boilerplate to define which fields are available, and in each field, what are the subfields, and there's a lot of code to type just to define your schema. And that was pretty annoying coming from a large code base. So that was my first motivation. I wanted to reduce the boilerplate to make it very easy. Secondly, I wanted a purely functional interface. That means that I wanted that when you look at the types of when you look at the function definitions, you would be able to understand what the function does. An example of that is that errors are explicit. So when you call Caliban, it's not going to throw an exception. Whatever can fail will be clearly stated in the type, and you can get a typed error telling you exactly what is the error. And finally, I wanted it to be very user-friendly. So with a lot of examples, good documentation, interoperability with many things. So let's look at an example. On the right side, this is a GraphQL type, as I showed you in the original example. So in order to expose that type on the server, what you need to do is just to create a case class in Scala that represent that type. And you can see on the left, they look very similar. And what Caliban will do, and I will show you a bit later how, is that from that Scala case class, it's gonna derive, it's gonna automatically infer what is the GraphQL corresponding type. So that is really nice when you already have some code and you want to turn it into GraphQL with minimum efforts. You can reuse your existing case classes and turn them into GraphQL automatically. So this is the user type. Let's see how about the query. The same as the previous example. So To express our query, we just create a case class named query with 2 parameters, one for each endpoint in our API. To express an argument, like here there is an ID in the first field user, there is an ID that is an argument. In Scala, we express it using a function. So a function from user args, which is another case class, to an option of user. You can see there was no exclamation mark on user, so in Scala, it's an option. If I remove the option, then there will be the exclamation mark on the GraphQL side. The reason user args is a case class and not directly a UUID is that we need a name for the parameter. So that's why we use a user args case class, just to give a name to that argument. Okay, so now what can Caliban support? Can you just use any case class and it will be turned to GraphQL automatically? So Caliban supports most of the Scala basic types, so int, string, boolean, list, option, tuple, and so on. They will be automatically transformed to GraphQL. That's pretty easy. It also supports some Java types like time, UUID. It supports future and also Zio and ZStream if you're a user of Zio. So let's say if it's a future of int, it will be just interpreted as returning an int from the GraphQL point of view. So it will automatically recognize that it's a future or a Zio and expose the type that is inside. Then you probably have a lot of case classes that are your own. Caliban is able to derive a GraphQL schema automatically for your own case classes and still traits using another library called Magnolia. So you basically have nothing to do except if you have inside your case classes some type that Caliban doesn't support. So if there is a type that is not listed here, you need to define how to transform that type into a GraphQL type, and then it will be able to derive the rest. So you only need to write code for a type that is not listed here and that is not a case class or a still trait. Otherwise, Caliban will be able to infer it automatically. There is also an interop module that adds extra support. So if you use Monix task or Monix observable or cats effect, Source, JSON, refine, and so on, those types are also supported using an extra import and an extra small dependency. Okay, so let's see concretely how to use it. So we have our case class query that I showed before. Now, how to expose an API for that query? Well, first we need to give the implementation of those functions, right? There is a get user and get users, but what to do if the user requests those? So for that, we create what is called a resolver to resolve each field. And a resolver in Caliban is just a value. It's a value of our case class that we created before. And for each field, we just call the proper function that returns the expected type. So for example, here, I'm calling user service.getUser, and we expect that this will return a user, or it could be a future of user or a Zio of user, a task of user, and so on. And for get users, I'm calling some user service.get all users. So this is simply a value of our case class that for each field, we'll call the proper function. Then we call, finally, we actually use Caliban. We call the GraphQL function, and we wrap our query object into a root resolver. Why do we wrap that? That's because GraphQL supports 3 types of operations: queries for requesting data, mutation for modifying data, and subscription to receive notification from the server. So in your root resolver, you can have a query object, a mutation object, and a subscription object. Mutation and subscription are optional. So in this example, I only passed a query object. So when you call GraphQL, you as a response, you get an API object, a GraphQL API object. What can you do with this? First, if you call render, this function render returns a string that is your schema in the GraphQL format. So if you just print it, like in this example, you can confirm that the schema that was automatically generated from your case classes matches your expectation. Then let's see how to execute a query. So here I just created a query that is a string, a small GraphQL query, the one from the example we saw before. So first thing, we need to turn our API into an interpreter. So an interpreter, when we create an interpreter, there are some validations that are done to verify that the schema is valid. And it will generate an optimized view, a view that is optimized for execution. It's recommended to do this only once. So when you start your application, you create your API, you create the interpreter, and then you can use the interpreter for all the requests. You can simply use execute on the interpreter. You pass the query string, and you get a result. And execute will take care of parsing the query, finding what fields were requested, calling the resolver for each field that was requested recursively, and then convert the result into the GraphQL response format. So that is great to test a query, but usually what you want is to serve your API. So you want to expose it by HTTP so that clients can actually use it. So for that, Caliban has 4 separate modules, one for each different HTTP library. There are a lot of HTTP libraries in Scala, so we had to had a lot of different modules. But those are just making it easy to expose your API using one of these libraries. So below, I put an example of how it is with HTTP4S. So you just call the function make HTTP service. You pass it the interpreter, and you get an HTTP route that you can expose on the port that you want. It's a HTTP4S object, so you can do whatever you want with it. It's the same thing for Aka HTTP, Play, Finch. You just transform the interpreter into an HTTP endpoint, basically. And this function, make HTTP service, takes care of exposing the endpoint and in the proper GraphQL format. It's yeah. Okay, so this is really really simple. So now I covered a basic example. Let me talk about a few more advanced features of Caliban. One problem that is very common with GraphQL is what we call the N+1 problem. So let's say you query an order, and then you have for this order, you have a list of products, and for each product, you want the name. So here is a naive way to do it. So you can have first you call get order to get your order information. And then in your order, you have a list of product IDs. And then for each product ID, you call get product to get the name of the product, right? So here I use 0, by the way, but I could use future dot traverse. That would be the same thing. The problem with this approach is that you do, let's say your order and the products are in a database, you will do one query for the order and then n queries for getting each product separately. So that is not optimal if you have a database. It will be pretty slow if you have a lot of products. The solution for that is a type we call zquery that allows using almost the same syntax as before. So you can see in this example, I barely just replaced Zio by zquery. But the difference is that behind the scene, you can do some optimization that will allow grouping all the requests for each product into one request. How does it work? So in addition to the previous slide, you have to write a little extra code. And basically that code defines how you can group several requests of the same type into one. So you need to implement a function from a list of requests to a map of results. And it will, when Caliban runs a query, it will try to group all the requests that are similar. It will not do them immediately. It will collect them and then group those requests that can be grouped together into one using your optimization function. It might seem a little complex because I don't have much time, but you can have a look at the Zio query project. Initially, this used to be part of Caliban, but it was extracted into its own project because this can be used not just in Caliban, but it can have other applications. So you can have a look at the library in detail. And I also have some blog posts and some documentation and a lot of examples to help. So if you want to have a look, that should not be very hard. Another feature that is nice in Caliban is something I called wrappers that allows you to customize many different steps of the query execution. So you can customize the parsing, you can customize the query validation, you can customize the execution, you can even customize each field execution or the whole thing with your own logic. For example, there are a few wrappers that are provided with Caliban. You can control the maximum depth of a query. You can control the maximum number of fields of a query and reject any query that has too many fields or that is too deep, for example, if you want to protect your API against bad queries. You can add a timeout for the whole thing or per each field. You can print slow queries. So all that comes with Caliban. It's just a few lines of code, actually. And you can, of course, make your own. It's pretty easy to do so. I was able to implement support for several Apollo plugins. So Apollo is a famous client, JavaScript client for GraphQL, and it has a lot of plugins. And I was able to implement support for several of those plugins using wrappers. So you can use wrappers to add your own logic, like make your own, add your own traces, log something, and so on. This is pretty convenient. It makes your API quite easy to extend. Okay, there are many more features that I'm not able to talk about because that would take too much time. But you can combine APIs together. So you don't need one big case class. You can have several case classes and then you combine the API objects together. There are some annotation to customize names and description if you don't want the same name in your case class and in your GraphQL type. You can also deprecate types with annotations. There is a code generation tool and an SBT plugin to automatically generate case classes from a GraphQL schema. So if you already have a GraphQL schema, you can bootstrap your Caliban project pretty quickly. And there are some extra features like schema, diff, support for Apollo federation, and so on. Okay. Now let me briefly introduce Caliban Client. Caliban Client was introduced later. It was initially not the goal of the project, but I realized that there was nothing in Scala for that, and that it was possible to apply the same approach, which is very low boilerplate, to writing GraphQL queries. Typically, what people do when they write GraphQL queries is they use a tool like I mentioned before, and then they copy paste the strings into their code. That is not great because, well, if the schema evolves, you don't get any warning, and you can do mistakes by copy pasting. It's hard to rename stuff and so on. Another advantage of Caliban Client is that you don't really need to care about fragments and aliases. Those are more advanced GraphQL features that are needed in some cases, but you don't need to care about it because Caliban will take care of it for you. So let's see a simple example of how to run a GraphQL query with Caliban in 3 steps. The first step is code generation. So there is also an SBT plugin for that. You run that SBT command. You give the path to the GraphQL schema. It can be online or it can be a file. And then it will generate some code for you to make it easy to write queries. So pretty simple. Just have to run this line and it might generate thousands of lines of code if it's a very big API. So here I put a little example. So you have a GraphQL type called location with latitude and longitude, 2 fields. And for that, it's going to generate a Scala type location with an object and then a helper method for each field. I'm going to show how to use it in the next slide. So now that you have all these objects with those functions, helpers, now you can just call them and combine them together. So for example, here I combine location.latitude and location.longitude. That means that I'm querying a location and I'm requesting those 2 fields. So below I put a longer query. So you can see that this is just basic Scala code. You are just using the generated code very easily. You start from the root query, then you can just type dot, and your IDE is going to show all the functions that are available inside query. So those are the root fields. So you type search, you see that it requires an argument, an option of string, you pass the value, and then it's going to require you a searchable object. So then you type searchable dot, and then you will see all the fields inside the searchable. You can pick station, open braces, and then it's going to request a station. So you can basically, you don't even need to look at documentation. You can just auto-discover, self-discover your API just using the Scala code and letting your IDE show you what's there. So that's how you create a query using Scala. Now, how to run this query? Well, that's pretty easy. Caliban client uses a library called STTP, which is very flexible and that lets you use many different backends. So you can use STTP with Future, with Zio, with Cats Effect. You can use HTTP. You can use HTTP4S client, I think, or any actual client library. So you just call 2 requests from your query object, and you pass a URI, and it gives you an STTP request. And then you can use send in the STTP library to call it. What is really nice is that not only is it calling your GraphQL API, but it is also parsing the result into a Scala type. So for example, if I go back, you can see that latitude and longitude, both selection builder objects return a double. So when you combine them, like here, latitude and longitude, you get a tuple of double. So when you call your query here, you will not receive JSON or some string or something that you have to parse. No, it's already parsed into a Scala object. So it is really easy to use. Okay, a few more things before I look at questions. What is the state of the library? I recently, it's been recently 1 year that I created the library. Over the last 12 months, it got a lot of feedback, a lot of attention. So there are about 520,000 GitHubs. That is pretty high for a new project. Several companies are using it in production already. And there are about 45 contributors. A few of them are from Japan, so I'm not sure if they are here today. Hello, if you are here, and thank you. So this is a pretty dynamic library with a lot of users and contributors. The next big thing that I want to work on will be support for Scala free. Right now, it has two blockers. The first one is the library called fastparse, which I'm using to parse GraphQL queries, and it's using macros. So I either need fastparse to publish for Scala free or use an alternative. And the second blocker is Magnolia, the library I'm using for deriving automatically the GraphQL types from Scala types. That is also using a macro. So same thing, either I need Magnolia to upgrade to Scala free, or maybe I could do without Magnolia using the new type class derivation features and maybe the macros in Dotty. I haven't looked at it too much yet, but that is probably gonna come soon. But except those two things, there is nothing else that is really challenging for working with Scala free. So that shouldn't be too hard to support. So that is my future to-dos. All right. Before finishing, as I mentioned earlier, I spend a lot of time writing documentation. So I invite you, if you're interested, to have a look at the website. The slides will be posted just after the talk, so you can click on the link. So there are some resources, some FAQ, there is some examples in the project. I also have a blog series where I explain, I have some examples with a little more details than today. And there is a GitHub project with the example as well. You can also go to the Zio Discord. There is a chat room called Caliban, which is pretty active. So if you have any question, feel free to ask there. Me and other contributors will be glad to help you. And you can also find me on Twitter at this handle. All right. So let me check the question channel. 5 minutes left. That's good. Okay. What means the exclamation mark in Caliban? Maybe so the exclamation mark, let me go back to my slide. I will go back to the beginning. Yeah, so the exclamation mark means that, so for example, ID here is non-null. It will not be null. It cannot be null. If there is no exclamation mark like age, it might return null. So in Scala, the equivalent is option or not option, basically. That is the meaning of the exclamation mark. Okay. Is there any other question? I can see people are typing. Yeah, it's like an option. It's the opposite of option because well, an option means that it might not be there. Well, it's just the opposite meaning of option. When there is an exclamation mark, it means non-null. Can zquery be used with cats effect? Good question. So so there is so Caliban has compatibility with cats effect. Caliban itself uses Zio under the hood. So the library, the interop library with cats effect is actually running the Zio under the hood with unsafe run. A bit like when you use, it's like almost the opposite way when you use HTTP4S with Zio. It's a cats effect. There is a cats effect under the hood. So I think it's possible, but you would have to use unsafe run to actually run the zquery. But I think it's possible. There is a project called Fetch that is using cats effect natively. It might also be possible to write an interop that transforms a fetch into zquery and zquery to fetch. I haven't tried that so far, but that seems feasible. Yeah, somebody posted the link to fetch. zquery is a little similar to fetch, except that it's based on Zio, so it has the Zio philosophy, let's say, of not like being more friendly. Like you don't really need to understand type classes, and you don't need any import. Just you can discover what's there out of the box. zquery also has some maybe some more features than fetch. For example, it's a little hard to explain, but it supports 3 types of execution. So you can run effects one by one, or you can run them in parallel, or you can also have a kind of pipeline where you can run some effects sequentially and some effects in parallel. So it's pretty flexible. But I haven't tried doing some interop for fetch. That could be an interesting project if someone is motivated. But otherwise, for using zquery with cats effect, I think you can just do it using the interop and unsafe run. Okay, there is another question. I really like the idea to support multiple frameworks by having had adapters. Oops, I have some experience to maintain libraries depending on Finagle and Akka. Okay, maybe there is another question, so you can read directly in Discord. Let me read the whole thing. Okay, so the adapters are, so today it's the same project, but different modules. So the adapters are released, when I do a release, I release everything at the same time. But I remember that the question was only asked about Play because Play has some versions, 2 versions that last for a pretty long time. And we considered, we considered that issue of splitting 2 different projects, or like splitting the adapters to separate projects. At the end, we decided to just support the latest version and keep everything together, just because it was easier to maintain. But actually, the adapters are just like if you don't use subscription, it's barely 20 lines of code to just parse, to just expose the GraphQL endpoint. That is a post, usually a post request, parse it, calling the execute method, and getting the transforming the response to JSON. It's so simple that it would be pretty easy for anyone that uses a non-supported version, let's say, to just copy this into their own project or making their own library if they wanted to. So for now, we decided to keep everything together. But later, yeah, if we could split the adapters, yeah, if we need to support several versions at the same time. Okay. All right. Any more questions? If not, then thank you for listening to me, and maybe see you next year in Tokyo.
ピエール・リカーダさん、あ、ごめんなさい。はい、ピエール・リカーダさん、発表ありがとうございました。これにて、質疑応答を終了して、セッションを終わりたいと思います。続きは、他に質問等ございましたら、ぜひ休憩時間中や、懇親会にてお願いいたします。ご視聴いただきありがとうございました。皆様拍手をお願いいたします。